What? Given array and this again could be taken as block array can be block subset of this. That is, there exists such that is this the order is so that no position is blocked or report that it is impossible. Sort A in ascending order, right? A is this. No position is blocked, right? The descending order. Oh, sorry, fuck. In 10 ANC. See in AFI, descending order should work. Descending A if for int अगर कोई दो सेम हो गए but let's suppose because this will be always be greater than that, greater than or equal to. If it's equal to, then it's false. For a bool fl is equal to fl is equal bool fl is equal to true for int I equal to be greater than an I plus plus I equal to 1 if a of I equal to a of I minus 1 fl is equal to false if fl c out yes until else c out no and just as this output. Okay, no, for okay for int I equal to greater than n plus plus then c out a of I c out and l c out minus 1, right? This should work. Uh, and then when this was run, I can submit from here. No, I cannot submit, right? Or I can submit from here. Okay. This should be this minus 1. Only 1 minus 1, right? This should work. because if I'm arranging in descending order, a of I minus 1 can be greater than or equal to a of I, and if a of I minus 1 equal to a of I, then we can use this as a subset and form a of I. So I will be blocked, but control conditions. Okay. Hmm. I should open the complete problem set once as well. Hmm. It doesn't exist. Each one has initial timer. Okay. This is that. Then the current what is this? To sneakily to meet his friend Gustavo and Danny. To do so, he must cross a path guarded by volunteers. Let me check the submissions. It is accepted or not in queue. But it should get accepted ideally because this is correct as suppose. Each volunteer has an initial timer. Initially at second 0, ith volunteer has an initial value of AFI. Each second all timers will increase by 1. Once the timer reaches it wraps around to 0. Okay, so AFI mod m, right? If at x seconds the ith volunteer is watching over position I, then timer is exactly 0. Okay, at any other time the distracted I will not notice. Okay, so after each m seconds they will notice, right? Because if it's 0, then they will notice at 0 plus m mod 0 bond m, which is 0. Okay, position 0 to the left of pointer to escape he must use position n plus 1. Okay, so he must use n, but okay, and for each second after choose to in his current position, move one position to the left or motion to the right. Note that actor can't go to the left position 0. Okay, and it got at the beginning of a second. So okay, so we need to tell whether there exists a strategy such that he can move there. So ideally he should be able to move, because when this turns 0 he should be able to move to the next position. But okay, so I just need to tell yes or no. So m is 5, yes, at the initial 0. So 1 second, so what Hector will do is, if he moves at ith second, let's suppose at jth second to left of I, so that j will be incremented to all the right positions. So if he make a choice to stay at a particular index I, then that I will be moved to sum across all n. So it's like if he doesn't move, makes a choice and he continues to move to right, then it should be I plus 1, I 0, 1, 2, 3, 4, 5 mod m, and so on. 1 plus a of I mod m, 2 plus a of I mod m, 3 of a of I mod m should not be equal to 0. So what we can do is we can first check all the values mod m and then check all the required values, right? The required. So if he reaches exactly at that time, he will have to wait, or else he will not have to wait. So we initialize time by this. Okay, just need to tell whether he can escape or not, right? In this case, he can't escape. Why so? Okay, let's suppose I just need to check. So if he can't escape when he is standing at I, he can stand at I for m minus 1 seconds, right? At max. He can make any possible permutation such that he stands at I to till m minus 1 seconds. But at that time, the another value should not be 0. So let's suppose for here, he can, if m is 2, so it should not be that these two simultaneous values are 0 at the same time. So okay, so if m simultaneous values are 0 at a particular time, he can't cross. That should be the answer. Why? Because see, if m consecutive values are, so he can move to m minus 1 value. So m consecutive values can't be 0. So we will replace each a of I with a of I mod m. Then we have to check like 1, 2, 3, 4, a of I plus 1 plus 2 plus 3 plus 4 plus 5 and so on should not be equal to this. So we'll add a of I, we make a of I equal to a of I mod m, then we'll add I to that each value, and then we will do mod m, right? Then there should not be a point where all the value, there should not be a consecutive subarray of size m such that all the values are 0. Is that correct? I suppose that is correct. because else he stands at this. Then he can wait till m minus 1 seconds here more. If he stands at this and he moves to the next, he'll have to move to the next. When he's at this and it becomes 0, he has to move it to left. He can't move to left, right? Oh, 1% to the left, 1% to the right. All right. So he can move to any position, na? So I think this is the answer. This should be key, because if it's 0, then he will move this towards this much back. He'll stay at 0th position. But if the first position is such that, so he will try to move this is 1 हुआ. So he'll move to the first position. Now he has m minus 1 seconds to be at this. Now it should not, in these m minus 1 second, he should be able to pass to this. Then if he makes sure he gets to this, then he can also move back to this, right? So it should be just this only. Key. Yes, yes, no, this is no, right? Because if he moves at 1, he has exactly 1 second to stay at 1, but both the arrays times are 0. So I just have to check this the length of this subarray. I think that is the answer. That should be the answer. One second. There should not be. I have to add if this is plus 1. So he will stay at position 0 until it's a favorable time. Then it will move to 1. Now he can stay at 1 for m minus 1 second. Now within those m minus 1 seconds, he has twice to move to 2. So he has m minus 1 seconds. So which means he can also move to 2 at a point, at any point, right? So he can move when 2 mod m becomes 1, and so on. Similarly, he can move to right, but he can't move just when if m is 3. Let's suppose 1 1 1. So he can move at 1 2 3 1. Now this will be 1 plus, this will be 2, this will be 0. Then can move to 2, then we can come back to this. So 1 1 1. So this is the same. So this x x x. Okay, so there should not be any subarray of size m minus 1 that has all the values, that is similar values. So if this is same and has size more than m minus 1, more than equal size more than m 1 2 3 4 5 6 7 8. So you can skip all the m minus 1 rows in a row. Or m minus 1 or m. 1 पे स्क्वायर 2 पे स्क्वायर 3 पे इस पे पहुंच गया 3, right? So int n, m or a of n, right? M, you can just input this a of I mod is equal to m. So if these values are same, they should not be same for more than m size. Because if it's equal to m, equal to or greater than equal to m, then int c is equal to 1, bool fl is equal to true, for int I equal to this I equal to 1, I less than n, I plus plus, if a of I equal to a of I minus 1, then c plus plus, else if c greater than equal to m, fl is equal to false, break, c is equal to 1, and this does this c plus plus if c is greater than equal to n, fl is equal to false, if fl, then yeah, else nah, yes yes no, yes yes yes. Hmm. Yes yes no, yes yes yes, I think this should work, because if there is a array of more than size m, then you can't move, right? Because you will encounter each value between 0 to m minus 1, so the size has to be less than equal to m, less than m, not even equal to m. I think this should pass. Hmm. Let me check, see. 27 solutions, I think I might be wrong as well, because you can move to left as well, right? You can move to left, and then he can wait. He can, if this is size n, he can't cross it in one go, but he can wait somewhere, just move back, let it reset, and then go. Hmm. So he can't move only when m is 2, or then 0 1 0 1 0 1 should be there, else he can move every time, because even if it's same, he can move 1 2 3, he can't go here, he can't go here, 1 2 3. No, but he will have to take the m moves, right? Let's suppose m is 4, 1 2 3, okay, 1 2 3 4, 1 2 3 4, no 1 2 3 4. Okay, so I think this should work, but not sure though. Hmm. This has less summations, like to 400. I might be wrong. Karam solved this. Status go to now there is p unit length segments. P unit length segments. P is of one length line segments, and Q L shape pieces. P is formed by two unit length segments at right angle. This you must use all these pieces with no piece left and use to form a grid of n cross m. Alright, given P and Q, determine whether there is a possible integer n m such that n can be possible. P is after this. N m. Okay, so I'll just need to tell whether n cross m grid can be formed using P Q segment. So whether it has passed or not, I don't even know. So what can be done for this? See, so n cross m grid, how many columns and rows it will contain? It contains m plus 1 columns and n plus 1 rows. So m plus 1 cross n plus 1, p pieces are there and q is 0. Then okay, if q is 0, let's okay, p and q are 1 obviously. So how many q pieces can be there? 1 2 1 2 3 1 2 3. See, pieces of length q will add 1 to this. So see, q will add 1 to column and 1 to row, right? And p will only add 1 to either of that. So with So how many queue you have, that many rows and that many columns you should always have, right? This many rows and this many columns I will always have, because, oh wait, it's not that, because you can add multiple. Oh, why it is not us working? Hmm. So you can add this. So uh, you will always add one to any of this. Hmm. 1 3, 1 p 3, 1 2 3, okay, and 4. This is working, right? I just need the confirmation for this to, this should not fail. Ideally, I think this should not fail. It has passed, right? Cool. What's the rank? Okay, 683. That is cool. Okay, now I can focus on this. So let's use all pieces, right? Now, can this work? Let's check that. So Q will add 1 to this, but when you add Q here, it will. So Q has a property. If you will add it anywhere, it will always increase. Okay, let's suppose Q is even, right? Q is even, then I can use Q in pairs like this, and then using Q in pairs, I can make the grid like this, right? 1 Q 2 3 4, and apart from that, now I have P's. If Q is even and P mod 4 is 0, this P is a multiple, P is mod 4 or P mod 3, because I can use 3 P's more to form these, right? And I will always require 3 P's it, anywhere, because like, no, here I require 3 P's, then this can be also made. Mhm. If this is this, so if Q is even, let's suppose the first case Q is even, make all of them using Q, right? And then you will make a some sort of a rectangle. Now you have two ideas. Either you'll continue to extend this rectangle, so you make a rectangle. Now you have P's left, right? Now to make a clone of this rectangle, how many blocks you need? You don't require this layer, you require this one, this. So this has, so let's suppose, one height and h column. So it will have h plus one these sticks. So this cloning will require h plus one this sticks. Then 1 2 3 4 5. So the h column plus h these sticks, h plus one these sticks, and h these sticks. So 2 into h plus 1 these sticks will be required of length q for this. Hmm. Right. So for any of length, if q is even, then you can do this, and you can even form on optimal. You can find, because you need n, right? You need this n, so n, and then p should be modulo this n 2 into n plus 1 should be 0. If such a n exists, then you can do. And what is the like limit? Limit is 10 to the power 8. So I think we can do it in, because it's 10 to the power 8. So square root of n, t is 100, right? So 100 into worst case 10 to the power 4, which means, okay. So first of all, first of all, let's suppose there will be any n cross m. Okay, I'm more complicating this. N cross m grid is exists, right? Then it will have n plus 1 cross m plus 1 sticks, right? Now if I make a stick using p and q grid, it will have how many? Q will have 2, 2 into q plus p, right? So if 2 into q plus p can be expressed as a product of two numbers such that both the numbers are greater than 1, because n plus 1 and m plus 1, product of two numbers greater than 1, then this should be an answer. But will it always be? Let's suppose p is 0 and q is some odd number. So this, this. So if it's odd, okay, and this, you require 1p. If q is odd, you require at least 1p, because 1, 2, 3, 4. No, you can't do this. You have to do this, then you have to do this, then you have to do this, then you have to do this. So 1, 2, 1 second. You can't even make this. 1, then you do 2, then you do 3, then you do 4, then you do 5. You cannot overlap, right? Hmm. Okay. Hmm. Got it right. Hmm. So, uh, the thing with Q is you can arrange Q only in this and this. Then after you have done this, you cannot place. So if you use Q in pairs like this, then you can't use Q. You can use Q here like this. Then you can use Q here like this. So which means you can use two Qs like this. Okay, 1 second. So there will be some. So if n cross m grade exists, it will contain n plus 1 into m plus 1 sticks. So, and in terms of p and q, it will contain 2 into q plus p sticks. So 2 into q plus p should have a factorization, say x into y, where both x and y are greater than 1. And to support this idea, p and q are within 1e8, which means we can use sqrt, which means we can solve this in order of sqrt n, square root of n, and t is also 100, so 100 into square root of 10 to the power 1e8, which is 1e4, should be 1e6. This should pass. So we'll have to, first condition is this: if this exists, then how many? We will have this much conditions. So if this have a prime factorization, okay, so it will have multiple prime factorizations, right? Now, okay, we can find all the factorization, all the factorization, right? And so how can we find? We can find all the divisors greater than this. We can store them in pairs in root and time for this, and then we can check whether can we have these many rows, x columns, or columns x rows, that works. So right now, for particular configuration, let's suppose x plus y, how can we check whether we can form x and y using p and q, right? So now we need to have two things. So now I boil down to this. So this is like 2 into p plus q. Find all the divisor pairs v1 v2 and just check whether this grid v1 cross v2 is possible using this or not, right? This is the whole question. So now whether this is possible or not, okay, let's suppose for x and y, how can we check? So using p we can make anything, right? But we will have to limit q. So we'll have to use q, and then we can use p as it is as we want. So we can use q like this, like this, like this, and like this. We can start using. So we have like x is x q's, minimum of this x, or we don't get this, so we can use this, then we can do this, then we can do this, and so on. So we can use, so what we can do is we can use these x q's like this in one column, then x q's another column, and so on. So how many rows will do? So q by x rows we will make, and in the final row it will be q mod x, and then we'll have to fix all the fill all the remaining using p's, because p is dynamic, right? So we'll need to fix q first, then we can just use this to fix this. I think that should work, right? So we have int pq, int p comma q, c int p q, int value is equal to 2 into q plus p, using a 6 up there. Now I need just to find all the value divisor pairs, right? Vector of pair of int comma int vp for int I equal to 2, I less than, because 1 cross this can be made. Okay, 1 cross m grid can also be made, right? 1 cross x grid can also be made. Why not this can be equal to also? Because m can be 0, right? So we can always make a grid like this 1. Am I correct in n plus 1 comma cross n plus 1? Am I correct in this? Because see, we will have m plus 1 column, right? So, and in each column we will use n rows, n this, right? So m plus 1 columns we have, and in that we will use n in each, then we will replace this with m this, then we have m columns and we'll use n plus 1 in each, right? So this should be mn plus n plus mn plus m, just right. Now if I m plus 1 into n plus 1, how much we get? Mn plus mn plus m plus n plus 1, which is wrong. It should be this. So I have m plus 1 rows, m plus 1, and n plus 1 columns. In each column I have n this. So m plus 1 columns I have. In each of that I'll have to use n segments. Then plus I also need to have n plus 1 rows in which I'll use m exactly m. right? So mn, which is m plus n plus 2 mn. So should be equal to 2 into p plus q. See, this, one second, right? N plus m plus 2 mn plus q should be equal to 2p plus q. Hmm. Can I factorize this even further? M 2 n plus 1 plus n. Can I express it as a product of something? Oh, I can do this n plus 1 into n plus 1. This is the mn plus m plus n plus 1. I'll have to do subtract minus 1 and add m n to it, which can be done as m plus 1 n plus 1 minus, no, this is some, so I can do this. Okay, 241, right? Oh, so that and this I needed. So it is not that difficult. Hmm. No, it should not be n plus 1 into n plus 1. N plus 1 into n plus 1. मैं कुछ मिस तो नहीं कर रहा ना? M plus 1 columns into n plus n plus 1 into m. This is the into m. They should exist two integers such that this holds. Hmm. Hmm. Or is there anything else that I'm leaving? Or is there anything that I'm missing out? M plus 1, n plus n plus 2 m. N plus 1 m. M mn plus n, mn plus m. So mn plus n plus 2 mn. यार इसको एज अ टाइम फैक्टराइजेशन एक्सप्रेस करना है, मतलब एज अ फैक्टराइजेशन एक्सप्रेस करना है बस. Then it could be done in square root n. Okay, let's suppose for any x exist, कोई m cross n exist, और भी condition है that I'm missing. So I know for each x comma y, अगर if x comma y is there, I can test that easily. If x comma y is I know, I can test that by placing q first because इस पे limit है, then p because p is flexible. If anything remains, if p remains or fall short, remains or fall short, it fails. Mn then n plus n plus 2 mn. sticks. So it fails. One second. If right, so if see, let's suppose if x is there and y is there, so x plus y plus 2 into x into y should be equal to 2 into q plus p, right? If x and y is there, then x cross y, this many form will be there, 6 will be there, they should be equal to this. Now, if x and y is this, then they should be equal to this. Okay, this value is known. Can I find x and y such that x plus y 2xy is equal to this in shortest time? Okay, let me just check how this value works. So if it's 1n, then it's 1 plus n plus 2n, right? If it's 2, 2 plus n, one second. This should have this. So one more thing, it always will fall exponentially. So if it's x cross n, then you can use x q sticks, so on till that value, and here you will use q mod x sticks, right? And then you will fill remaining this. So x, how many p's you will require? You will require x p's just to fill this side, y p's, x plus y, x p's to just fill this side row, this is this, y p's just to fill this row, and all the remaining p's to cross form to form that additional grid that falls like this. This you will use addition. Let's suppose you form till here, right? And you leave here. So you need y piece just to form this, and x piece just to form this, and then this part you will need to form using p's, and this part you will need to form using keys, which is just you need this much value, which is less than this, which is v mod x minus v mod x. These many values you will have to fill using this, and then this value is also you will have to fill using this. This value is also for this, which is again the same, x minus v mod x, and then okay, so I can just do this, but how can I tell what x and y is required? Hmm. What x and y is required to solve this? How can I tell this? Hmm. 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 2, 3, 7. 2, 5. 2 5. 2 5 should be 2 plus 10 12, right? And 2 2 is 2 plus 2 plus 2 times 2 is 8, which is 12. This should be equal to this. Then I need to find the values. I can just check if I know n. Okay, see, one more thing. Because this is till 1e8, so both the values can't exceed 10 to the power 4 simultaneously. Because the grid will be always constrained in 10 to the power 4 cross 10 to the power 4. Means both the sides simultaneously could not exceed this. So which means there is a lesser side which is always less than 10 to the power 4. So I can iterate to all the values in 1 to 10 to the power 4. So I know n also, right? Now I know the x as well. So this should work. I know x, right? Now y will be equal to y. See, I know x as well. Okay, let me share what I know. See, if I know x as well, x plus y plus 2xy is equal to some value val, right? Now I know x, so y plus 2 something into x y is equal to val minus x, which I know y 1 plus 2x is equal to val minus x. Now val minus y is equal to val minus x upon 1 plus 2x. This should be divisible and then should be the value, right? Correct. So right, I know this can be done. And if I use y in any order, I'll have to use y just to form a grid. I can use it this way as well, but it will always eventually lead to this. So cool. And I is equal to 1, I less than equal to sqrt square root of val I plus I less than equal to this. I can just add 10 for a suitable factor just to make sure this. So int now j, and I'll just do bool check. It will take int x comma y, int p comma int val. How many values there? No, int should take int p comma int q, and then check return true if p is 0, return p equal to 0. It will just return if p is 0. I'll implement the logic right now. J should be val minus I. See, int j is equal to minus 1 for if val minus I modulo 1 plus 2 into I, y into 1 plus 2x. If val minus I, this value modulo this value should be equal to 0, then j is equal to val minus I by 1 plus 2 into I. If this is this, right? If j is not equal to minus 1, I will just do bool fl is equal to false. I don't know, but if any of the configuration satisfies this, if check of I comma j comma p comma q satisfies this, then make fl is equal to true. If fl, then yeah, else no, it should not work, right? And I just need to just implement the check function. So this, so int row is equal to, अब x बनाने हैं तो x यूज होंगे हर उसमें, but I have q piece, so q by x. So these many rows I can make. Int rem is equal to q mod x, because I'm using x in each, so q mod x will be required remaining. Now int required p is equal to, if p equal to required p, ठीक है, required p कितना होगा, it should be first of all x plus y तो होगा, because this and this तो p ही बनेगा, but if this is required, right, y rows हैं, तो अब जो बचे हुए 3 कॉलम इसने भर दिए, ठीक है, if lem equal to 0, which means it has filled these rows, right, now the remaining rows will be, कितनी remaining rows हैं, y int y minus r, this is required, this is remaining, so इसमें तो सब भरना पड़ेगा, this is y, this is x, it will have to fill x how many times, remaining plus 1 times, or is this required p plus is equal to r into x, r plus 1 क्यों नहीं कर रहा, बिकॉज नीचे वाला हमने पहले कंसिडर कर लिया, एंड देन 1 2 3 4 एंड y कितनी हार है, p plus is equal to r into r, वन रो में 1 2, इसको y पर फिल करने पड़ेंगे, राइट, y नहीं x फिल करने पड़ेंगे, इस रो में इसको कितने, ये कितने लगेंगे, राइट, इसको लगेंगे x प्लस y प्लस 2xy, ये बना 1 2 3 4 5 6 7 8 9 10 11 12 13 माइनस x माइनस y, सी हार इंटू एक उसमें लग रहे हैं x दिस, तो हार इंटू x, और एक छोर पे लग रहे हैं दिस टॉप वाला भरने में, तो हार इंटू y एज वेल, required p is this, else सी लास्ट रो तक गए, मैं भरने लगा, मैंने ज़्यादा ही भर दिया, दिस विल आल्सो बी अ केस सिमेट्रिकली एज वेल, तो कोई नहीं, एक में चेक करना, एंड बाय माइनस आर, इतना तो भरना ही है, अरे यार -1 r कॉमा 0 0 लॉन्ग लॉन्ग, ठीक है, बिकॉज इतना तो तुम्हें भरना ही है, बिकॉज ये हो गया, तो इतना तो तुम भरोगे ही, बट दिस प्लस 1, जिसको भी कंसिडर कर लिया, तो ये भरोगे ही, इसके बाद ये तुमने भर दिया, ये तुमने भर दिया, बचा ये, विच इज इतना तुम्हें भरना है, लेक p प्लस इज इक्वल टू q mod x, required p plus is equal to q mod x, q minus q mod x, sorry, q minus q mod x, इसको तुमने भरा, एंड देन इतना तुमने ये भरा 3, फिर इतना ही तुमने ये भी भरा, नहीं इतना ये भी भरा, यार क्यू पी प्लस इज इक्वल टू, दो बचे ना, एक दो ही तुमने भरे, दो तुमने ये भरे, 2 टाइम्स ऑफ दिस, इतना तुमने ये भरा, इतना तुमने ये भरा ना, नहीं नहीं, if fl is this, fl is true, x is equal to I, y is equal to j, break, if fl, c out xy, और माइनस वन एक बार करना है कि नहीं, ऐसा माइनस वन एक बार करना है ना, if fl c out x y and else c out minus one and I suppose this should work. Segmentation. Oh, oh, oh. J is equal to this. If J is not equal to this, if L minus this upon this plus y is equal to 0, right? Is this तो हो चुका है. हाँ, इसकी जरूरत नहीं है. But I suppose square root of value plus 10, this should work now. Because this is the minimum thing, right? One is minimum, one of them is always minimum than square root of n, the minimum side. That is for sure. Both can't be greater than this. If j is not equal to minus 1, then do this. So there is no way where this is becoming true. तो into q, p q, right? यही है ना, पहले p है then q है. What is this thing? यार इसमें भी जा भी रहा है. See out. Ah, yes. इसमें वो जा भी रहा है चेक कंडीशन में. Yes, इसमें जा रहा है. Not equal one. See out j करते हैं ना. J. Oh, no. See out I. J. Oh, 1 second. Oh, nice. I suppose ये छोटी सी issue है. नहीं माइनस नहीं दे रहा है हर बार. एक बार देखें. हम्म, हम्म, हम्म. No, no. What are you doing? No, no. I'll have to check X, Y. No, no. I have to check X, Y, not P, Q. I have to make this right. R is Q by X. Okay. 1 second. 1 3 में 1 2. जब 1 और 2 जा रहे हैं तो क्या दिक्कत आ रही है. 1 2 जा रहे हैं राइट. 1 2 1 X Y P Q. 1 2 1 3. I think there is some. Refresh. 1 2 पे नहीं है वो. Lap true. 1 2 2 मेरा. ये चक्कर हो जाएगा. उनको टू बनाना है. Okay, 1 second. If also if R is greater than this, then Y. Because 1 2 3. So R is greater than Y. ठीक है. लिख जा 1 second. If R is less than Y, then they should do. No, रुको 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 रुको. Oh, there's one error in this. If R is less than Y, else if R equal to Y and Q mod X equal to 0, else right. If R is equal less than Y, then this will happen. If R equal to Y and this is this, then if P equal to X plus Y, return true. Return false. Else this is done. Now कुछ बचा है. Now I can't place this anywhere. If q greater than 1, return rem is equal to q mod x. If rem greater than 1, return false. If rem equal to 1, if p equal to x plus y minus 2, return true. Then false. Okay, minus 1 2 1 2. ओके तो इसमें तीसरे पे भी गलत दे रहा है. तीसरे पे 5 1 आ रहा है. 5 1 पे भी 1 2 आना चाहिए. 5 1 और 1 3. 1 3 में आंसर क्या आता है? 1 3 में है 1 प्लस 6 यानी 7, और 5 1 में है 5 प्लस 1 यानी 7. तो गलत क्यों है? int val is equal to 2 into q plus p. सेवन है राइट, 7 है तो q i 1 है. r is 1, and if r equal to this and q mod x equal to 0, this is this. And then this is this. This should be 1 cross 2 है ना. वन on 1 राइट. I will always take max of this, right? ठीक है, ऐसा कर लेते हैं. k1 is equal to max of p comma q and q2 is equal to min of q comma q. I'm just pq ना, p k2 k1. Okay, k2 k1. Polygon, this is this, right? up to into 1 है तो कितना रिक्वायर्ड होगा? 1 2 3 4 5. नो नो, दिस इज राइट. वो तुमने किया. नहीं नहीं, ये गलत नहीं है. pq इसकी जरूरत भी नहीं है. it should be this is also required to fill. let's suppose तुमने इतने भर दिए, तुमने 1 करा. if this is equal to y, x is 1 2, right? 1 2 will satisfy. 1 2 जब 2 1 है तो नहीं है, तो 2 1 में क्या है, आर एस 2 ओवर 1/2 which is 0, remainder is 1, required p is 3, the remainder is 1, if remainder is this, y which is 2 which is 1 minus 0 minus 1 which is 0 0 0 2 into, एक सेकेंड, जब आई मेड दिस तो ये तो रिकॉर्ड होगा, तो 3 तो है। अब एक काम करते हैं, इसमें एक भी नहीं भरा, तो 0 जो है इसमें तो कुछ भी नहीं लगेगा, बट जो इसमें है q is 2, q is 1, okay, q will always be minimum of this, no q तो यूज होगा, मैं कुछ गलत कर रहा हूँ, x है, x है, x करना है, दिस इज q mod x which is this one, 1 mod 2 which is 1, मैंने अगर बंद भी किया, एक सेकेंड, 1 क्रॉस 2 बनाते हैं और 2 क्रॉस 1 बनाते हैं, दोनों बना के देखते हैं, 1 क्रॉस 2 required is 1 1 1, ठीक है, दिस इज 1 1 1 1, एक सेकेंड, कितना टाइम बचा कॉन्फ्रेंस में, ओ ओ इसकी जरूरत नहीं थी, ज़्यादा समस्या आ रही है, 2065, नो, this should have been solved by now.